Hello friends, in this lecture video I will be talking about how to find the inverse of lower and upper triangular matrix, right? So before getting started we shall just look at what a matrix is, right? So a matrix is a rectangular array. Okay, so let me just okay, so we shall just look at what matrix is, right? So a matrix is a rectangular rectangular array of numbers, right? Okay, for example, if I take a matrix A, then it can be a size of anything, right? So we will just say n cross m, right? So n means number of rows, whereas m means number of columns. Okay, so here we will have entries, right? So it will contain n number of rows and m number of columns, and in each cell or in each entries we will have scalars, right? Okay, again we will just see what an inverse of a matrix, right? So for example, let's say if this matrix is A, then A inverse can be denoted as A inverse, like this, right? Now again, if I have A and if I multiply A by its inverse, then I will get identity matrix, right? So this is the basic definition that we can give for A inverse. Okay, now we have the traditional way for finding out the inverse of any matrix. Anyhow, I will be talking about an incredible easy way or shortcut for finding inverse of lower and upper triangular matrix, right? So now we have to see what a triangular matrix is. Now a triangular matrix, in the sense, now if we divide the matrix through its diagonal, and if we have zeros, okay, for example, now let's say we have a matrix and I just divide this matrix through its diagonal, and the elements above this diagonal or below this diagonals are 0, but the rest have values, right? So in such scenario we will call those matrices as triangular matrices, right? So we have two types of triangular matrices. First one is lower triangular matrix, and we have upper triangular matrix. Okay, now I will just denote this lower triangular matrix using the word L, and it will be in the form of A, B, C. Now if I consider a 3 by 3 matrix, right? So if I consider a 3 by 3 matrix, A, B, C, then D, E, F, then the rest will be 0, right? So you can easily remember that the entries including the diagonal elements and below the diagonal element will be having some values, the rest will be containing 0, right? So this is how you can remember how a lower triangular matrix will look like. And if I take an example for upper triangular matrix, then it will be in the form of A, B, C. Here also I am taking a 3 by 3 matrix, A, B, C, then D, E, F, right? So the rest will be 0, right? So here if I consider this, here also you see, now this is the diagonal, these are the diagonal elements, and the elements below the diagonals elements are 0. Okay, so this is called upper triangular matrix and this is called lower triangular matrix. Now we will see how we can find out the inverse of such a lower triangular and upper triangular matrix, right? So now we will just start with lower triangular matrix, right? So let me take lower triangular matrix L is equal to now I am just taking 3 by 3 matrix, right? So A, B, C, D, E, F. Then this will be 0, this will be 0, this will be 0, right? So using reduce, using the traditional way of finding the inverse, you can go ahead. Otherwise, you can just use this shortcut. Now I will just tell you how you can easily, with one line you can find out the answer, right? So in such case, we can easily find the inverse of L inverse. Now you see, we have a point, right? So the inverse of a lower triangular matrix also will be a lower triangular matrix, right? So this is the first point that you should remember. So since this is a lower triangular matrix, the inverse also will be lower triangular, right? So now the corresponding elements for this entry, and this entry in the inverse of the lower triangular matrix also will be 0, right? So I can write 0 here, 0 here, 0 here as well. Now we have to find the entries in the diagonal of the lower inverse of the lower triangular matrix. For that, what we can simply do is you just write down the reciprocal of these of the diagonal entries in the original matrix. So this will be 1 by A, this will be 1 by C, and this will be 1 by F. Now again, I have to find out the entries coming here. Okay, so for that, what you can do is, if you have B here, and if you want to find out the corresponding elements in the inverse of L, then you just want to negate the value, right? So if we have B, then you should write minus B divided by the multiplication of the entries in the diagonal elements of that element in the diagonal above and adjacent to that entry that you are considering, right? So here you see you are considering a B, then you have to just consider the elements right near and right above that entry, right, in the diagonal element, right? So here you just consider the multiplication of this A and C, so and you just divide it by the multiplication AC, right? Again, if you want to find out the corresponding entry for E, then again you have to put minus E. Since we have positive E, then you have to put minus E divided by again the multiplication of the entries in the diagonal right above and right adjacent to that entry, right? So here CF. Then again I have to find out the element here. Let me name it as X. Now for X we have an equation, right? So X will be equal to, now you see we have to find out this the entry corresponding to this element, right? So let me use a different color. So what you have to simply do is you just want to multiply this and this, right? So BE then minus CD, like you do for finding out the determinant, right? So here BE minus CD divided by the multiplication of the diagonal entries, so that will be ACF, right? So using this formula you can easily find out the inverse of this lower triangular matrix. Now we will just look at an use case. Okay, so use case or example. Okay, so let me take a matrix called A, and the matrix is given as 2 0 0 3 4 0 1 5 6. So in such case we have to first make sure that the matrix given is a lower triangular matrix. So definitely this matrix is a lower triangular matrix. So the inverse also will be a lower triangular matrix. So I can I can write the entries corresponding to these zeros straightforward. So this will be 0, this will be 0, again this will be 0. Now again I have to go for the diagonal entries of that inverse. Then I can use the reciprocal of the diagonal entries in the original matrix. Then it will be 1 by 2, then this will be 1 by 4, then this will be 1 by 6. Now I have to find out the entries corresponding to these entries. Then I can simply write, since we have 3 here, then I have to put minus 3 divided by the multiplication of these two numbers, that is 8, right? Again I have to consider the corresponding entry for this 5, then minus 5 divided by the multiplication of these two, then 24. Okay, 24. Now I have to find out this value. Let me take it as x. Then x is equal to, you just consider these, right? These. Then the determinant, like the determinant, 3 times 5, 15, minus 1 times 4, right? So if I write in this way, then you can easily understand, right? So 3 times 5 minus 1 times 4 divided by 2 times 4 times 6. So the answer will be 15 minus 4 divided by 48. Then this will be 11 divided by 48, right? So we have just found out the inverse. Okay, so this x I can just substitute here. Now we will go for an upper triangular matrix, right? So the upper triangular matrix will be in the form, I can write in this way: U is equal to A, B, C, D, E, F, then the rest will be 0. Okay, so for finding out the inverse of this upper triangular matrix, then again you have to remember this point: the inverse of an upper triangular matrix also will be an upper triangular matrix. Okay, so you have to keep this point in mind, and we can just work on finding out the inverse of this matrix. Let me take it as U inverse. Then again these entries will be 0, right? So I can directly write those and like we did for the lower triangular matrix, again I can find out the diagonal entries of the inverse by putting the reciprocal of the diagonal entries in the original matrix. So this will be 1 by A, this will be 1 by D, this will be 1 by F, then this 0, this is 0, this is also 0. Again, what you have to do is, if you want to find out the corresponding entry for this B, then like we did there, minus B divided by the multiplication of these two entries, right? So minus B divided by AD, then here also minus E divided by the multiplication of these two entries, DF. Then I have to find out this. Then let me take it as Y. For finding out Y, what you have to do is you have to use this symbol, right? So now EB. Okay. So again you have to consider this as the determinant. Then BE minus here you have to change the order, right? Here you have to just change the order. Okay, I'm sorry, here you have to just change the order. It will be like this, right? So now you see okay, now this point you should bear in mind. For upper triangular matrix you have to just change the order. How you have to multiply this is, you have to multiply C by D first and then minus BE. Okay, so since this is a shortcut, you have to just remember this order. So Y will be equal to CD minus BE divided by the multiplication of the diagonal entries, which is A, D, F. Okay, using this formula we can easily find out the inverse of upper triangular matrices. Then I will just look at an example here. So let me take the matrix as A. A is equal to let's say 1 okay, so A is equal to 2 3 4 0 4 2 0 0 3. Okay, so now I have to find out A inverse, which is equal, which will be equal to, definitely here the inverse also will be an upper triangular matrix, so 0 0 0, then this will be 1 by 3, this will be 1 by 4, again this will be 1 by 2. Now I had to find out the corresponding element for this 3, so minus 3 divided by the multiplication of these two, 8. Then again this one, minus 2 divided by 12, right? 12. Then I had to find out this Y, so Y will be equal to, now 4 times 4, right? So 4 times 4 minus 3 times this. Okay, 6 divided by okay, so again I made a mistake here. Now okay, right, so even though if it is upper triangular matrix, you don't need to change this order, so this equation is wrong. So what you have to do is, for finding out Y, then again you have to consider these 4 elements as we find the determinant of these elements. We have to just use BE minus CD divided by ADF. Okay, so I just realized the mistake I made. So you just want to consider this as a cofactor, and you have to just BE minus CD. Okay, so again if you apply this equation here, then it will become Y is equal to 6 minus 6 minus 16 divided by the multiplication of these entries, 2 times 4 times 3, that will be equal to minus 10 divided by 24, that will be equal to minus 5 by 12. Okay, so the A inverse will appear as 1 by 2 minus 3 by 8 minus 5 by 12, 0 1 by 4 minus 1 by 6, 0 0 1 by 3. So using your traditional way, you can check if this method works, and if you find this useful, you can use, and in the examination you can just use this method for double checking your answer. Now with this idea, we will be just doing another type of question. Let me just write down the question over here. Right, so question, okay, so the question says, let A is equal to 1 P Q 0 T R 0 0 T. Okay, so now what you have to do is, we have to find out where P Q R are real numbers such that T squared is equal to 1. Show that, now we have to show that A inverse is equal to 1 minus PT PR minus QT, then 0 T minus R 0 0 t, right? So this is what we have to do. So now if you look at the matrix A, now it appears like a lower triangular matrix. Okay, so what simply I can write down A inverse like this. So 1, the reciprocal of 1 is 1, then this will be minus P divided by 1 times T is equal to T, then again this one. Okay, so this one will be PR minus QT. Okay, so PR minus QT divided by then the entire multiplication of these diagonal entries, which will be T squared, then this will be 0, this will be 1 by T, this will be minus R divided by T squared. Okay, then again 0 0 0, no, I'm sorry, so this will be 1 by T. Okay, so 1 by T. Now you see the answer is quite different from what we have obtained as the inverse. Now in the answer we do not have T, right? So the T in the denominator has disappeared. So what you can do is this is times 1, right? So definitely this is 1. Now instead of this 1 I can put this T square. So again I can write in this way also, right? Because they are commutative, because the scalar multiplication of my matrix is commutative. So T squared into 1 minus P divided by T. Okay, PR minus QT divided by T squared, then 0 1 divided by T minus R divided by T squared, 0 0 1 T squared divided by T. I'm sorry, I have made a mistake here. So I just want to multiply this by T squared, then again this also by T squared. Okay, so now if I simplify this I will get the answer, right? So here no, I have just multiplied, so I don't need to write this down again. Wait. Okay, so let me just undo all these. Okay, so this will be equal to 1 minus P divided. I have just want to write down the entries here, 0 0 1 divided by T. Now if I multiply all the entries in the matrix by this T squared, then I will obtain the answer, right? So here 1 times T squared, so this will be T squared, then minus P divided by T, then PR minus QT divided by T squared into T. So this T squared will disappear, right? So okay, I am multiplying all these entries by this T squared, right? So now what I will have is, now this is very simple as it is. Okay, so now 1 times T squared will give you T squared, then minus PT into T squared minus PT, then again this T squared will cancel, again 0, then T, then this T squared minus R, 0 0 T. Okay, so this should be the answer. So this is what we wanted to show. We have just okay. Again you see here T squared is there, but T squared is already equal to 1, so you can just substitute this T squared by 1 and you have got the answer. So in this video I have just explained how to easily find out the inverse of an upper and lower triangular matrix, and I have just discussed the different type of question also. This is like a miscellaneous question. So hope we will meet in the next video, and I hope you might have enjoyed this video. And if you find this video useful, just like this video, share with your friends, and don't forget to subscribe to my YouTube channel. Thank you. So until I meet in the next video, bye.